Hi ladies and gentlemen, this is Mr. Green and this is another in my lessons on geometry. We're going to continue talking about trigonometry. And in talking about trigonometry, whoops, didn't want that, wanted that. In talking about trigonometry, we're going to take up a couple of more functions in trigonometry. So, don't forget, look at quiz corrections. Make certain you've got everything corrected you want to have corrected out there. Don't forget due dates. You get past a due date and something's got a 0. Really bad situation. You want to make certain you get all your zeros taken care of. So, trigonometry. We're going to look at the sine of a function. What is the sine? Well, sine is using the same angles that are in the triangle, but looking at a couple of different sides for the ratios over what we looked at with the tangent. The sine is actually defined as the opposite side divided by the hypotenuse. Now you notice in the tangent we use the two shorter sides, right? We use the opposite side divided by the adjacent. This time we're going to use that same opposite side, but we're going to use the hypotenuse. Okay? Now I want you to notice, because the hypotenuse is always the biggest side, the sine is always going to be less than 1. Why? Because if I'm dividing by a bigger number, it's always going to be less than 1, that what we will be getting. So, looking at this, sine of angle A. Well, here's angle A. Finding the opposite side, I would go to the opposite side of the triangle, that's A. And so I'm going to take A divided by C. Okay? Just to relate this for you, the tangent of angle A was going to be A divided by B. See how these are different, right? These ratios are not the same. But the sine is always going to be A divided by the hypotenuse, A divided by C. Similarly, if I look at angle B up here, my opposite side is side B. I would be B divided by C. Okay? So, that's what the sine is. Now, there is another function, the third function. It's called the cosine. Very similar to the sine in that I'm going to use one side and the hypotenuse again, right? But this time I'm going to use the adjacent side. So if I'm looking at the cosine of angle A here, my adjacent side is going to be this one. It's the one that's next to it, not the hypotenuse. And I'm going to divide by the hypotenuse. So it's going to be B over C. And the cosine of angle B is going to be the adjacent side, A, divided by C. Now I want you to notice the sine and the cosine are exactly opposite each other. If I took the cosine of angle A, I had B over C. But the sine was A over C. But if I looked at the other angle, it was B over C. And so they're just looking at the opposite angles, aren't they? Interesting. So, how do you remember these three sets of functions? This is where a couple of abbreviations and acronyms come into play, and you might have heard these in the past. One of them is SOHCAHTOA, and that's SOHCAHTOA. What does that stand for? Sine, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, opposite over adjacent. SOHCAHTOA. It's just one of those words. It's a funny little word that you can help remember it. When I was going to school and teaching, one of the teachers looked at me and said, "Some old horse caught another horse taking oats away." It was an acronym. It was a sentence. It was a stupid little sentence, but it helped him remember SOHCAHTOA. Okay? When I was growing up, my mom used the one that said, that was Oscar and Oliver have had algebra. And that was sine, cosine, and tangent. And I was looking at the ratios at that point. It just is a matter of use some acronym to help you remember sine, cosine, and tangent. You need to make certain that you've got them identified and you can remember them because you will be using them at least in this particular set of lessons. Okay, so if I wanted to find the sine of A is right here. That's the angle that we're looking at. Opposite, that'd be A divided by the hypotenuse. A divided by C. The cosine of angle A, that's the adjacent side. That's going to be B divided by C. If I'm wanting to find the sine of angle B up here, my opposite side is side B. That's going to be B divided by the hypotenuse, C. If I'm looking at the cosine of B, it's going to be A divided by C. You can see the ratios here. These two are the same and these two are the same. All right? If that helps you, you can help remember it that way. So, what is the sine of angle A? Angle A is sitting right here. Well, the sine of angle A is going to be opposite 16 divided by the hypotenuse, 20. That's going to be, let's see here, dividing by 4. That's 4 over 5, which is 0.8. If I wanted to find the sine of angle B, which is this angle up here, it's going to be 12 divided by 20. That's going to be 3 over 5, which is 0.6. Do you see how those worked? Good. Let's look at the cosine example. If I'm wanting the cosine of angle A, it's going to be the adjacent divided by the hypotenuse. That's going to be 12 divided by 20, 0.6. If I'm wanting the cosine of angle B, that's going to be 16 divided by 20, 0.8. Okay? You want to see those done on a calculator. It's not that big a deal. All I got to do is take the 12 divided by 20, and it will be 0.6. If I wanted that angle, I would take the inverse cosine of 0.6, and I would get the angle for that one, 53 degrees. Okay? You guys see how I'm doing that? Well, that's what this next one was. Inverse sine and cosine. If I wanted to find the inverse sine to find the measure of angle L. Okay? Well, sine is opposite. I don't know that opposite side, so I can use cosine here. So I could say the cosine inverse is going to be equal to 5.66 divided by 8.54. And that will tell me what that angle is. So I'm going to actually do that. I'm going to press second cosine. It gives me the cosine inverse. And I'm going to put a parenthesis, 5.66 divided by 8.54. See, I didn't even work that out. I just put it all in one sentence on the calculator here. And I got 48.48 or 48.5 degrees. Okay? Oops. It moved. So that's equal to 48.48 or 48.5 degrees. Okay? Do you see how I found that angle? Now I could find K over here by doing the inverse sine, but I could also just subtract it from 90 and get 41.5. How did I get that? Why did I subtract it from 90? It's 180 degrees in a circle. Already had a 90-degree angle. So subtract 90, that gives me 90 left. Subtract 48 from 90, and it gives me 48.1. That's how you can find all the angles in a triangle. Okay? Now, little bit of a history lesson. Why were they doing this? Why were these Greeks doing this? They had this ship sitting out here in the ocean, or out in the Aegean Sea at that point. Okay? And it's sailing along. It's their enemy ship. Okay? And they've got a catapult sitting down here on the shore. Shore sitting right here. Okay? Catapult with a big stone on it. And they want to throw that stone out there, but they want to know how far to throw that stone. what they would do is they would set up a tower over here with a man standing in it, and he was looking out here, and he was looking for a particular angle. He knew that this could be considered a 90-degree angle, and he would look until he got a particular angle here. And when he saw that ship at that particular angle, he knew what the catapult was set at, and he would say, "Fire!" And they would fire the catapult and have a real accurate shot at hitting the boat. That's why they use it. Military application for knowing when to fire a catapult, because they knew how far the catapult threw the rock. And they knew how far this distance was here. Okay? And because they knew this distance and they knew how far the rock could be thrown, all they had to do is get to the right angle, and they would say, "Okay, we're at the right angle, fire it," and it would hit the ship out there in the Aegean Sea. Protecting themselves. That was the way they were using this. Okay, I've kind of given you the history lesson. I've shown you where the sine, cosine, and tangent are. I've given you an acronym for remembering it, 3 of them as a matter of fact. It's now just a matter of memorizing those acronyms and knowing how to use them. We'll be doing more with trigonometry here in the next lesson. I'll talk to you next time we're together.